Okay, so let's first, we're going to be graphing sine and cosine today. Let's first focus on graphing sine. Now remember, recall on the unit circle, these are exact values for sine and cosine. Because we're focusing on sine first, if you don't want to listen to my lesson, that's fine, but you can't talk because you're ruining my video. Once again. Okay, so recall on the unit circle, sine is the y values. This allows us to get exact answers for sine and cosine, correct? So notice I've highlighted my y values to keep your eyes in the right place around the unit circle. So what we're going to be doing is, we're going to be graphing sine on an xy chart here, or on a theta, f of theta chart here. So it's going to be, instead of on the unit circle, on this xy chart. So let's just start by plotting points. If you don't know how to graph something, plot points. So first of all, 0, we're going to be able to do as many points as we want. We could do 0, pi 6, pi 4, pi thirds, pi halves, but that's a lot of points. So I'm just going to pick points that are pretty. Like, I don't want to have to do fractions and stuff. Do you guys see what I'm saying? So I'm going to pick, like, this point, this point, this point, this point, and then we're back to the start. Do you guys see? Because those are whole numbers, so I'm just choosing to plot pretty points. So let's start. At 0 degrees or 0 radians, I always do radians, so at 0 radians, sine is at 0. Agreed? So we have 0, 0. Now from there, our sine is going up to a half, then up, then up, then up. Now at pi halves, we're at the value of 1. Then we're going, and after 1, we're going back down, 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 till when we're at pi, we're at 0. And then at 3 pi halves, so I'm just going around the unit circle, at 3 pi halves I'm at -1, and then back to 2 pi, and I'm back to 0. That is one cycle for sine right there. Why is it one cycle? Because now won't we just start over? Yeah. The pattern will just start over again. So let's just look at graphing that. So here's my x-axis. Here's my x points. Here's 0, pi halves, pi, 3 pi halves, 2 pi, and then I'm just plotting points. Over 0, 0, over pi halves up 1, over pi up 0, over 3 pi halves down 1, over 2 pi up 0. So look, as I connect the dots here, it's creating what's called a sinusoidal wave. A sinusoidal wave. Yeah. Now we know, even though it looks like I've stopped, we know it doesn't stop. We can go around the unit circle again, and we would just now create another sinusoidal wave. You guys see? And can't I go backwards around the unit circle? So I'd just be going like this. Now we know that the domain for sine is all real numbers. That's because we can continue around the unit circle both ways. So I've only graphed one cycle, but I want to point something out. For one cycle for sine, this pattern always happens. So you're going to want to remember this. You're going to hear me say it through the lesson a lot. So for sine, our pattern went 0, then it went up to the maximum, then 0, minimum, 0. So you're going to hear me say that a lot. 0 max, 0 min, 0. That will be the pattern for sine. So I can even continue filling in. The pattern will happen again. 0, then it will be max, 0, min, 0. So if on the test I said graph 5 cycles, it'll be really easy for you to fill in. You guys kind of see what I'm saying? Now also, if you think about it, we're just continuing around the unit circle. So to fill in the x's now, here was 4. We're going in pi halves chunks because that's easy. So from here, this was 4 pi halves. This would be 5 pi halves. Then right here, we're now at 6 pi halves, which is 3 pi. Then 7 pi halves. And then now 8 pi halves, which is 4 pi, and that makes sense because look, there's another cycle and it's a length of 2 pi. So we end up 4 pi. So understand these dots actually, they just continue on forever. So I could draw this in, I can do as many cycles as I want. Now we are going to ask you on the test to draw in 2 cycles. So I would recommend drawing in 2 cycles on your homework. Okay. Questions on sine. That's the parent function for sine, agreed? Let's do the parent function for cosine. So now graphing y equals cosine of x. So now we're doing the same thing. We're going to pick easy points. So 0, then we're going up to pi halves, then pi, 3 pi halves. We're going around the unit circle, 2 pi. Let's do 2 cycles just for kicks and giggles. So then it'll be 5 pi halves, 6 pi halves, 7 pi halves, 8 pi halves. But now we're going to look for cosine. So cosine is x, so notice I've highlighted my x values. So it's 0, no it's not, it's 1, then it's at 0, then at -1, 0, and then we're back to 1, and that's one cycle. So let's draw in one cycle. So up at 1, -1, 0, pi halves, filling in my x's, pi, 3 pi halves, 2 pi, and then the pattern for cosine was over 0 up 1, over pi halves 0, over pi down 1, over 3 pi halves 0, over 2 pi up 1. Now the pattern will continue, so it's going to be the same thing. Now what's the pattern for cosine then? Max 0 min 0 max. Max 0 min 0 max. That's one thing you're going to hear me say for cosine over and over again. So that might be something you want to write down. The pattern for cosine for one cycle is max 0 min 0 max. So now filling in the other cycles will be easy. It'll be max 0 min 0 max. So this is actually still a sinusoidal wave technically, so it's going to continue forever. It's just technically a shifted sine function. Cosine is just a shifted sine function. We won't really get into it. I mean, technically, I bet some of you can see it. Where did sine start? 0. Max 0 min 0, correct? So it's shifted. Right here is the start of sine, isn't it? So cosine is just a shifted sine function, but we don't have to get into that. I'm just pointing out this is still just considered a sinusoidal wave. So if I did another cycle for cosine, I would just continue with that same pattern. Okay, let's test your abilities. Oh, no, sorry. Before we test your abilities, write these things down. Okay. Learning some new vocabulary. Here's what sine looked like. Here's one cycle for sine. 0 max, 0 min 0. Now, period is a new word to us. Period, you've got to really understand what it means. So everybody focus. Period means the physical length on the x-axis of one cycle. Now, the one cycle for sine was this pattern. 0 max, 0 min 0. So on the x-axis, what is the period, or what's the physical length of that one cycle? 2 pi. Questions on that? Okay, now our amplitude is the distance from the midline. Our midline is just the halfway distance, the halfway point of the total distance. So really, here is our midline at 0. Our amplitude is distance from the midline. So do you guys see how we're going up 1, down 1? Our amplitude would be 1. It's the distance from the midline. So it's 1. So cosine, let's look at cosine. Cosine has the cycle max, 0, min, 0, max. And period is the same thing, the physical length of one cycle. The one cycle for cosine was the max, 0, min, 0, max. What's the x-axis for that? 2 pi. So our period for cosine is 2 pi. And our amplitude is distance from the midline. So once again, up 1, down 1, so our amplitude is 1. The domain for both sine and cosine, we know can go on forever because we can go around the unit circle over and over again. So our domain is negative infinity to infinity. And aren't we, for both of these, bouncing between -1 and 1? Okay. Now what's going to happen, guys, is now we're going to take these parent functions, here they are, and we're going to just start doing things to them. Now, for example, let me point something out. If I took this sinusoidal wave up here, this one right here, and I took this and I squished it back this way, pulling it back this way, squishing it back in, and now it looks like this, what would my new period be? Pi, right? I didn't draw it perfectly, but it would be pi, because you guys see how the length of one cycle is now pi? Yeah. You're going to see how that happens in the equation in just a second. Now also, I could take and stretch this out like this. How much of a cycle has been completed now for sine? A half of it, right? It was 0 max 0. Isn't that the half mark? Does that kind of make sense? So our period can change depending on how we squish and pull out things horizontally. And our amplitude could change. I could now go higher and lower. So that's what you're going to see next. That's our first change. Before I do that, though, I just want to make sure you guys are really, really confident with the pattern for sine and cosine. It's going to make a world of difference in making the lesson hard or easy. So sine, if I gave you this and said graph, you could literally just start going with the pattern. What is the pattern for sine? And now I would create my sinusoidal wave, making it nice and round. Oh, missed that.
It's still nice.
It's still nice, thank you. Now cosine, you'd say, okay, I can graph that. Max, 0. And there's our...
Is the cosine one called a sinusoidal wave too?
It's just considered still a sinusoidal wave. You guys are awesome. Okay, here we go. Let's change our amplitude right away. Everybody, quick. So amplitude is distance from the midline. So amplitude is multiplied in front. A times in front, just like with all the other functions for the year. If we have something multiplied in front of our function, remember that's a vertical stretch or compression. That's also considered our amplitude. So note, a negative will not be a negative amplitude. Amplitude is distance. There's no such thing as negative distance. So negative is just a reflection over the x-axis. Now, if you remember back to all the other functions we've done and shifting from parent functions, isn't it true that what's times in front affects your y values? It won't affect your x values, correct? So if you look at this right here, you would say, okay, now we have a 2 in front. So my amplitude is 2. So now the pattern will be the same, guys. Look, it's for sine, we know it's 0, then it's max. Now our max, instead of at 1, is up at 2. You guys see? The amplitude is stretched out to 2. So 0 max, 0 min, and now it's down at -2, 0. 0 max, 0 min, 0. So it just affected my y values. It was vertically stretched out. Everybody good with that? So just for kicks and giggles, I plotted just so you can see it. This isn't necessarily drawn to scale, meaning it's kind of hard to draw to scale when we freehand it. So let me just show you. Here is regular sine. Red is regular sine. And blue has an amplitude of 2. But you guys see how they still have the same zeros? It's just now the max is at 2 instead, and the min is at -2 instead. So this is a little bit more drawn to scale. So understand our drawings today, to make our life easier, are not going to be drawn to scale. My amplitude of 2 is going to look like an amplitude of 10, because I'm just going to label it. Does that make sense, everyone? They don't look the same, though, actually. Okay. Okay, so now let's get into if the amplitude changes, we understand we take our y values and times them by the amplitude. Now we're going to get a period change, everybody. Period change means length of the cycle is going to change. The length of the max 0 min 0 max will change. The length of the 0 max 0 min 0 will change. So right here, the b value is going to be times in front of x. That is, everybody, b is the number of cycles from 0 to 2 pi. That is really important to understand. B is the number of cycles from 0 to 2 pi. Or in other words, the frequency. How frequent we have a cycle from 0 to 2 pi. Well, if that's the case, then the period, the physical length of one full cycle is going to be this formula. Period will be 2 pi divided by b. Okay, so let's look at, for example, y equals sine of 2x. We see that we have a 2 in front. That literally says we have 2 cycles from 0 to 2 pi. Does everyone agree that that's what that formula says? So now here is, guys, let's say right here is 2 pi. Normally sine looks like this. 0 max 0 min 0. That's a normal sine. But that's only 1. Now it's happening twice from 0 to 2 pi. 2 of those 0 max 0 min zeros are happening from 0 to 2 pi. Does everybody see? So now it would be 0, max, 0, min, 0. 0, max, 0, min, 0. Now there's 2 cycles. You see how it's like squishing it in this way? Well then if that's true, guys, what would the period be? Period means length of just one cycle. Pi, does everybody see? Well, that would make sense, because look, here's the formula, 2 pi divided by b. 2 pi divided by 2 is pi. Okay. So if you think about it, we took our x-axis, and now the length of one cycle was cut in half. The length of one cycle was cut in half. Does everybody have this written down, or do you need more time? Okay, let's practice then. Here we go. Graphing y equals sine of 1/2 x. What's my amplitude? Number of cycles from 0 to 2 pi. There's only a half a cycle. Therefore, one cycle's length will be 2 pi divided by b, so divided by a half, which is 4 pi in length. Now that makes sense, guys. If only a half a cycle is from 0 to 2 pi, to get to the end of one full cycle, I'm going to have to go twice that amount, which would put me at 4 pi. So this is how you're going to do it on the test to make your life easier. You're going to say, here's the parent function, y equals sine of x. Then you're going to write down the parent function's points. Let's just do one cycle for now. So remember as we went around the unit circle, 0, pi halves, pi, 3 pi halves, 2 pi. There's one cycle. Good enough. Then for sine it was 0 max, 0 min, 0. Now we've got to change the period. Now right here, that's the x thing. Period is length of a cycle. Right now the length of a cycle is 2 pi. We need it to be 4 pi. So what do we need to do to our x values? Times it by 2, don't we? So we're going to take our x values and times them by 2. So now write down your new points. 0 times 2 is still 0. 2 times pi halves is pi. 2 times pi is 2 pi. 3 pi halves times 2 is 3 pi. 2 pi times 2 is 4 pi. Do you guys see how that fixes it for us? And then our y values, nothing changed. 0, 1, 0, negative 1, 0. I also want to point out now that we times by the reciprocal of that, didn't we, to our x's? We times by 2? Does that, everybody see that? That's always going to happen. Okay, so then you would literally just graph it. Like on the test, you'd say, okay, 0, 1 pi, 2 pi, 3 pi, 4 pi. Then you said your amplitude's 1, negative 1. And then you're just plotting points. So we're not drawing it to scale, obviously. Make them nice and round. If you make them pointy, that's not good. It's a wave, not a point. Okay. So guys, it's technically like really stretched out this way, like horizontally, because really normally don't we have a full cycle right here? So once again, not drawn to scale. All good? Next one? Go on. Okay, answer the amplitude. 3. Number of cycles from 0 to 2 pi. 2, if that's the case, what's my period? 2 pi divided by 2 is pi. Okay, then you'd say, okay, my parent function is y equals cosine of x. So then 0, pi halves, pi, 3 pi halves, 2 pi. Then for cosine, it's max, 0, min, 0, max. Agreed? Yes? Oh, it's not. I shouldn't say 2 pi. Good catch. 2 cycles from 0 to 2 pi. So then from there, since our amplitude's 3, that's a vertical stretch of 3, so we're going to take our y values, times them by 3. Now our new period needs to end at pi. It's ending right now at 2 pi, so don't we need to times by a half to get it down to pi, to end at pi. Now notice once again we times by the reciprocal of that. That's always going to happen, just pointing out. 0 times a half is 0 pi halves, times a half is pi fourths. Then we have a pi halves. Then we have a 3 pi fourths. Then we have a pi. Don't say it like that. You're so annoying. somebody was going, fine, you might as well say, shut up, you dumb idiot. Like, agree? I think that's what it sounds like. When somebody's saying it like that, I don't care. That's what it sounds like when you go, fine. 3, 0, negative 3, 0. Yeah, you know what? And I know I'm going slow, but there's people out here going like this, like a maniac. So I know some of you can go faster than others. You gotta be patient. Okay. All right. 0, pi fourths, pi halves. I'm just saying there's people that need to go a little slower. So I know I'm dragging on for some of you, but too bad. So, and then you just plot points, obviously. Questions? No? No? Yes? No? Does that make sense? Okay. I won't do any more of that caliber, but I need you to tell me what I would do here. So, right here, what would I do? My amplitude is 8, obviously, correct? So I would times my y values by 8. What would I do to my x values? Times them by 2. Okay. What about this negative? Good point. So amplitude's not negative. Our amplitude's still 2, but the negative does reflect it, correct? So all we have to do is still times our y values by negative 2. Then it will reflect it for us. It'll all work out. Does that make sense, everyone? Okay. Now notice our period didn't change in this one, so our x's wouldn't change, but our y's we would times by negative 2. Okay, let's go on to when you will see things even more advancedly. Let's just get into all the shifts now. So shifting for all functions works the same. So if I had a quadratic, you would say the shift is right 1, up 3, stretch of 2, correct? Yeah. Right 4, up 3, stretch of 2, reflection over the x. Left 1, down 4, stretch of 3, reflect over the x. Left 3, down 5, stretch of 4. Agreed? Well, shifting for sine and cosine works the same way. So let's look at this. A is our amplitude, which is also the stretch or compression. B we've already seen is the number of cycles from 0 to 2 pi, which helps us find our period, the length of one cycle, which is 2 pi over b. And now we're just going to add in a shift left and right. This is our shift left and right. We go opposite, just like we do in all these examples. This plus k is added on the outside, just like with all these examples. It's shifting up and down, and the sign stays the same. So nothing new, because we've learned all this stuff before. Now here is one thing to note. If you do have B and C, you have to be really careful with your shift left and right, because technically you can't do a shift left and right unless it's just a 1 in front. So before we do a shift left and right, we would have to divide by B. So it's actually, this would be a shift of right C over B. We're going to have some examples like it. If it's just a 1 though, that's completely, it's just right C. Then remember, the negative is a reflection over the x-axis. So all we're going to do is shift from the parent function, everyone. Okay, let's just get right into all the hard ones. Here we go. Y equals 0.5 sine of x minus pi thirds. What's my amplitude? Number of cycles from 0 to 2 pi. That's your B. 1, so our period is still 2 pi, agree? So, because it's 2 pi divided by b. And then we're shifting right, pi thirds. And then there's no shift up or down. Okay, so what you're going to do is go to your parent function. I've already written down the parent function points to save time. But you would know how to get them, correct? You sure? Y equals sine of x. Yeah, and then unit circle. Okay, so now we'd say our amplitude's a half. That we would times our y values by a half. Check. Now the number of cycles from 0 to 2 pi, really our period is what matters. Our period needs to end at 2 pi. It already does, so we're good. And then right pi thirds. So that's an x shift. So we're going to add pi thirds to our x values. So everybody, you have to be able to add fractions correctly. 0 plus pi thirds is pi thirds. Pi halves plus pi thirds. 5 pi 6. Pi plus pi thirds. 3 pi halves I think this one was wrong. Isn't this one wrong? Let's say you didn't know how to add fractions, guys, or you wanted to be quick and efficient. Couldn't you just type into your calculator, look, 3/2 plus a third, math, enter, enter. You couldn't type the pi part in, but yeah.
Is that for the 3 pi?
The 7 pi 6 is wrong.
Is that one good?
Yeah, it's 11 pi 6. Okay, everybody, so then from there you would say 0, 1/2, 0, -1/2. This is only one cycle, and then 0, right? Then I would label my x. Do you need me to continue graphing that, or could you plot points after that? Speak to me, besides these people. You're short. Because really on the test, what I would do is I would look and see, do your points match up with mine? And then does your graph look somewhat right? Okay. Okay, awesome. Okay, this one, getting a little bit more and more advanced each time. Our amplitude is just 3, but then we would say a reflection over the x. So then from there, number of cycles from 0 to 2 pi, a third. Therefore, our period is 2 pi divided by a third, which is 6 pi. All right, we're shifting no shift left or right. We are shifting up 5. This one I do need to graph all the way through. So if we look at this right here, our amplitude, technically we're timesing our y values by -3 first. Then after that, we're adding 5, aren't we? Those are both up and down shifts, or y shifts, basically. But now we have to change our period. Right now it ends at 2 pi. It needs to end at 6 pi. So we need to times by 3. Guys, look, we're timesing by the reciprocal. You're going to want to remember that. Okay, so times by 3. So let's write down our new points. 0, 3 pi halves. 3 pi. 9 pi halves. 6 pi. Let's just do one cycle for time's sake. 0 times -3 is 0. Plus 5 is 5. 1 times -3 plus 5 is 2. 0 times -3 plus 5 is 5. -1 times -3 plus 5 is 8. 0 times -3 plus 5 is 5. Now everybody listen, on the test, if you don't draw in a midline, I'm going to mark it some points off. So you just want us to draw in midlines. Okay. 1, 2, 3, 4, 5 is my midline. Agree? Why is that my new midline? Because my old midline used to be at 0. So you'd go to 5 and draw in a new midline. Now from there, I'm going to continue labeling. Aren't I going to be up at 8 and 2? 5, 6, 7, 8. And then 5, 4, 3, 2. And then we're going to label our x-axis. So 0, 3 pi halves, 3 pi, 9 pi halves, 6 pi. And then from there, you're just plotting points. This part's the easy part, right? Over 0 up 5, over 3 pi halves up 2, over 3 pi up 5, over 9 pi halves up 8, over 6 pi 5. And then looking at your graph here, does it make sense? It's reflected, so that makes sense. 0 min, 0 max, 0 went down first instead of up, and it shifted up. Okay. Let's look at one with a B and a shift left and right. So everybody look. This is a shift of left 1. This, though, is a shift of left a fourth. Does everybody see where I'm getting a fourth from? Right here is a shift of right pi. This, however, is a shift of right pi halves. You got to remember that. You see how I'm doing that? Okay, so let's do, this can be our last, well, yeah, this will be pretty much our last example here. So everybody, I would write this one down so that when you get to your notes, this is as far as it can get. This is every shift. So y equals 3 minus cosine of 2x minus pi. What about that 3 in front? Yes. Yep, it's the same thing as up 3. I rewrite it. Okay, so now you can say, okay, that's a reflection over the x. which affects your y values. So let's go right down to our y values and say times our y values, our parent function, by -1. We're going up 3 after that, so add 3, agree? Our amplitude's 1. The number of cycles from 0 to 2 pi is 2. Our period is 2 pi divided by 2, which is pi, agreed? We're going to write pi halves because you've got to divide by 2. So now you can say write pi halves. And then we're going up 3. So we've already taken care of on our parent function the up 3, the reflection. Now right here we've got to go fix our period first before we shift left and right. Right now our period is 2 pi. It needs to be pi. We're timesing by the reciprocal of that. So aren't we timesing by a half? Then after that we're going to add pi halves. So there's going to be some major fraction algebra here, which is not bad. We can do that. So obviously this one's really easy. 0 times a half plus pi halves. That would be pi halves. Now this one, guys, would be this. Look, pi halves times a half, which is pi fourths, plus pi halves. And then you would get a common denominator or do it in your calculator. So 3 pi fourths. Right here we're going to have pi times a half. So pi halves plus pi halves, which is pi. Can I just give you the rest? I just wanted to show work on a couple of them. So then that would be 5 pi fourths. Then it would be 3 pi halves. Is that one full cycle? Yes. 1 times -1 plus 3. 0 times -1 plus 3. This will become 4, right? 3, 2. Where's my new midline? So at 3 you would draw your midline. Then I'm going to go up to 4, right? Oh wow, this is not drawn to scale. And then from there, my x-axis here is 0, pi halves, 3 pi fourths, pi, 5 pi fourths, 3 pi halves, 5 pi fourths. And then plotting points. Pi halves up 2, 3 pi fourths up 3, pi up 4, 5 pi fourths 3, and then back down to 2. Questions on that? Okay, the only thing I want to show you, we won't graph this one, but people, if you don't see an example like this, they freak out because it is weird at first. The first time you see it, it's weird. This next example. So, answer me just these following things. What's my amplitude? 2. It's a reflect over x. Now, people get freaked out right here. The number of cycles from 0 to 2 pi. 3 pi halves. Don't let that freak you out. You guys, that's just a number. That is approximately 3 times pi divided by 2. It's just a number, like 6.3 or whatever. You know what I'm saying? It's just a number, so yeah, that's fine. Our period is 2 pi divided by b, so divided by 3 pi halves. We have to be able to flip fractions correctly. So look, 2 pi divided by 1 times by 2 over 3 pi. So in this one, my pi's end up dividing out, and I get 4/3. Does everyone see? That's okay. We can have an x-axis without pi on it, and it's no big deal. So now from here, we're shifting, no shift left and right, up 5. So just a question for you. We would go to our y values, we would times them by -1, then add 5. The hard thing for people is to figure out what to do with their x's, but don't. What have we done the whole day with this? Times by the reciprocal. So you'll take your x values and times by 2 over 3 pi. And all the pi's will end up dividing out. And there will just be numbers on your x-axis, which is fine. Okay? Yes? Don't worry about it. Good question. All right, and on all these, they should divide out. Awesome questions. Okay, that's the end of the lesson. So you have like 25 minutes.